So on page 39, we started to talk about scenarios where items are replaced. All of our scenarios, for the most part, if I asked you to draw a card, we were assuming we were putting it back, right, to draw another one when it was the or scenarios. But if you're told no replacement, okay, that's a classic giveaway for being dependent events, okay? So I will add that to your notes later, but this is a classic indication. These are dependent events. Like your second probability is going to be affected by the first one. All right. So we talked about, right, grabbing a green and a red. If things are being replaced, these are called independent events. Independent, meaning what happens first doesn't affect the second or the third because we keep on putting it back, right? In this case, marbles. It could be cards. It could be anything like that we're replacing, okay? I have to say this. Will a die, if you roll a die, will that ever be dependent if you roll a die? Like if you roll a 5, you record the 5, but you're not taking it away from your total outcomes, right? Like you're not stripping that number off of the die to roll again, right? So a die is always going to be independent. Spinning a spinner, always going to be independent. So those things are not what we're talking about. We're talking about marbles, cards, anything that you remove from the mix, right? Then you know something is changing. So under independent events, nothing changes in terms of the total. We kept the 9 intact, the 9 marbles. When we were dealing without replacement, we went from 9 to 8. So the total, we could right away tell this is changing. So even if I just gave you this, you should be able to tell, oh, wait a minute, these are dependent events, like something has not been replaced, okay? Just by looking at the denominator. So we went green and red. So we had 3 greens out of 9. We take that one out, so you're down to 8. In terms of red, we had 2 reds, so it's 2 out of 8. So you multiply, and that was your probability. When we grabbed 2 of the same color, 2 blues, for instance, we went 4 out of 9. And then again, 4 out of 9, because we're replacing that first one we're drawing. And so nothing changes. Under this side, it was 4 out of 9, and then we're down to 8, but because the first one was a blue one, the top number changes also, because we're taking the same color again. Okay, so this is a bit more of a change compared to the previous one. So now I asked you to do the rest of this page here. So let's see, I didn't post the key, and that's, I kind of wanted to go over it today. Blue and a green. So I have to make sure I get this right. There are 4 blues, right, out of 9 on the first draw. And then you're down to, you're back to 9 because you're putting it back. And how many greens are there? There are 3 greens. So 4 times 3 is 12. 9 times 9 is 81. Okay, so that was your probability there. A blue and a green here under this scenario. You grab a blue. There's 4 out of 9 chances of that happening. Okay, now you're down to 8 because you're not replacing. And how many greens are there? We still have the 3 green that we had from the beginning because we were not drawing a green previously, so this is 3. So 4 times 3 is 12, 9 times 8 is 72. So that's how you do the probability, okay? 2 green marbles. So this is probability of green and green. So we have 3 green out of 9, and we have 3 out of 9 again for our second draw because we are replacing, okay? So that would be 9 over 81. 9 goes into 9 one time. 9 goes into 81 one time, 9 times, right? So this is technically a quick way to simplify. 2 green marbles here. We've got 3 out of 9 on our first draw, right? And then we're down to 8. And because we grabbed the green one first, we're now down to 2 green ones for our second draw. So 2 times 3 is 6, 9 times 8 is 72. Okay, so that's how that goes. And now, the tougher one. I would say, though, this is a classic question. This is one of those staple, like drawing two of the same colors or two of the same kind. That is classic, so I would like you to highlight this and maybe even have that on your study sheet if you have room. Two colors that are the same, two like-colored marbles. That's what you're trying to say here. That's what you're trying to come up with. What are my options here? If you want two of the same color, you're talking blue and blue, right? Or green and green, or red and red. So you got to consider all of those three cases. Okay, so we have to go probability of green and green, or probability of red and red, or probability of blue and blue. You have no other choice. You can't just say, oh, it's when there are two green ones, right? You don't have a choice. You have to consider all cases. So case 1, case 2, case 3. Okay. So green and green, we'll just go, we are replacing in this scenario, right? So it'd be 3 over 9 times 3 over 9. Red and red, we've got 2 over 9, and grabbing another one, so 2 over 9. And then it's blue and blue, which is 4 over 9, 4 over 9. And just clean that up. 3 times 3 is 9 over 81. I wouldn't reduce until the very end on these ones, because it just makes it easier to add them if you keep the denominators the same. 2 times 2 is 4. 9 times 9 is 81. Here it's 4 times 4 is 16. 9 times 9 is 81. And then you add them all up. Okay. So what do we get there? 39. We have 9 and 4, that's 13. So 39. 39 over 81. No, 29. No. Who said Mr. Dirksen? Yeah, I was wrong. I heard you. 29. And it's not even Monday. 29 divided by 81. Not that you need to. I'm just going to leave it like that. That is technically, if you gave me that answer on the exam, or this is usually going to be a short answer question. It's not going to be a multiple choice question. It's way too much work involved, okay? If you left it like that, you're fine. If you divide them, let me just get this right here. You get point, I'll go comma, because we are rounding, 0.3580 technically, if you want it as a decimal. Okay. Now, what if we go to the other side without replacing? Okay, no replacement. I'll write that down one more time. Dependent. I want this to really sink in today. The province sometimes just asks you, how do you know things are dependent here? Do you think these events are dependent or independent? You're going to be looking for, are things replaced when you remove them? Right? Something like that. So no replacements. So again, we would go the same route. We would go 3 over 9. So we'll go green and green, red and red, blue and blue. We'll add those up. So for this case here, we can use this to help us out. It's 3 over 9, and then it's what? 2 over 8. Because they're the same color, so the total goes down by 1. And since you grabbed that green one, you're down to 2. Plus, I go to the next one. 2 over 9, and it's 1 over 8 next. those are the red and red, grabbing two reds, plus 4 over 9, and then it's 3 over 8. That's how it changes if you're not replacing. I'm willing to put money down that if they ask you for a question like this, that it's going to be no replacement. Usually it's no replacement, but read carefully. So there is 6 over 72. This is 2 over 72. This is 12 over 72. So we add this up. This is 6 and 2 is 8 plus 12 is 20. 20 over 72. You can reduce that. Let's go slice it in half, right? You can divide them both by 2 because they're even. 10 over 36. Keep slicing it in half. 5 over 18. And that's as far as it goes. That's one strategy if you don't know how to reduce, if you don't know exactly the biggest common factor, just keep dividing by 2 as long as they're even. Keep doing that until you can't go further, and then it might be divided by 3 or divided by 9 or something like that, right? 5 to 18, and so if you want this as a decimal, right, that'd be 0.277. This keeps on going. It's 7s all around, so I'll just go 7, 8. I'll round it to 7, 8 if you want to round it to 4 decimals. The reason why I round it to 4 decimals is that if you wanted to quickly turn this into a percentage, you could just shift the decimal, and this would also be correct. That's why I do that. But technically, on an exam, if they asked you to state it as a decimal and you went 0.28, that would have been okay. Unless it's money. Never round money to more than 2 decimals. Okay? That's a fast rule. You can't change that. Okay, so let's go to the cards next on page 40. So when it's a standard deck of cards, it's just 52, right? Total is 52. You got to remember that. You've got your 4 suits. You've got your, right, face cards, aces, all of that stuff. So 3 cards are being drawn, one after the other, without replacement. Without replacement. Determine the probability. Here's another, right? It's a probability now. So you're going to have something stacked, right? You're going to have a fraction when you're doing this. You're drawing a red card, a black card, and another red card. So how many reds do I have to get to start? 26 out of 52. That's probably a red. Next. This one is gone. You've removed one. So you're down to 51. And how many black cards are still there? There are still 26 black cards. Because this one was a red one. So you still have your 26 there. And your last one, you've removed 2 cards. So you're down to 50. You're drawing another red card. How many red cards are left? You removed 1, right? So you're down to 25 for that third probability. So this is how you would set it up. And so this would be, you can shorten this, right? You can go, just multiply the top, that's 16,900. You multiply the denominators, you get 132,600. If you, one thing you can certainly do is you can cross out 1 0 with another 0 in the denominator. That will make it a lot easier to read. So that's your probability. If you're trying to turn that into a decimal and it's too small, just leave it as a fraction. Okay. So I'll just circle that. That's my answer. Odds. It's asking to state the odds as well in favor. What are the odds in favor of this happening? I'll tell you this, even if it had said odds right from the beginning, I would have turned it into a probability first, and then I go to odds next. Okay, so we've got 169 to 1326 minus 169 like that. and that would be 1157, like this. Remember, this is it happening, right? 169 times, and it not happening is 1157. That's what you're comparing when you're doing odds. Probability is 169 times out of a total of 1326. Okay, so there you have it. You're drawing a red queen, a black ace, and a face card. So let's do that. Red queen, we have 2 out of 52 are red queens. You're down to 51 for the next one. We know that for sure. Black aces, we still have all 2 black aces there. And our next one is 50. A face card. How many face cards are left? 11, right? Because the first one was a face card. This is also a face card. I'm just going to write that down here. So you're down to 11 face cards. So when you multiply that all out, you get 44 over 132,600. The denominator is not surprising us because we're still always going down by 1. So the denominator will stay if you're dealing with the same question. I'm not going to reduce it. I'm just going to tell you, hey, this is technically, we're good. And so if you want to write these as odds, we go 54, and on the other side is this 132,556. And let's say this is a multiple choice and you're stuck and you're like, how do I reduce this? I hope you remember. If you want to reduce odds, actually always write the first one, the smallest first, and then go divide it 132,556. And then you go math, fraction, and what happened there? It couldn't do it. It couldn't do it. I'll try to reduce the math, fraction. I couldn't do it. I do know they're both even though. So I do know I can divide them both by 2 for sure. And probably divide them both by 4. Yeah, I can divide them both by 4. So if you don't mind, just the reduced version, dividing both of them by 4. Okay, you got 11 over 33,150. And 11 is a prime number, so I know that I can't break it down any further. But this is your reduced answer. Okay, drawing a blackjack, a red jack, and a face card. Okay, so we've got 2 blackjacks. We are down to 51. We still have all 2 red jacks. And we're down to 50 now. How many face cards are left? This is a face card, guys. Face, face. So technically 2 faces have been removed. Yes?
For the face card, wouldn't you only select 5 out of 50 since you're only selecting a red face card?
For this last one here? For filling in this, you're saying 5 to 50?
For B
You still, probability is always out of the total. So if it's a blackjack, there are 2 of them out of a total of 52, right? So your probability, your chances of that happening, you always have to have the total at the bottom. Is that what?
But I mean, it's 5 out of...
This here? Because for this one, we're only interested in any face card. Doesn't have to be red or black. It's just any face card. This will have to be 10. Because you used to have 12 face cards. Yes, you grabbed a blackjack out of it and a red jack out of it, but you're still down to 10 now for faces in total. Does that make sense? If it had said a red face card, you would have had to be careful. How many red face cards are there? Normally 6, right? And since you grabbed a red jack already, you would be down to 5 there. If I had specifically said red face card. Make sense? Okay. That would be what? 40 out of 132, 600. We cancel the zeros. You at least have this, right? You can reduce it further. This would be 4 to 132, 5, 6. So I subtract 4 from the total to get my other number on the other side. Drawing an ace of spades. How many ace of spades do we have? There's only one. Yeah. Spades is your suit, right? Ace all the way to king. So there's only one. But you're down to 51. Ace of hearts, there's only one. And a red card. Ace of hearts is red. So you can write that down. Like ace of hearts, it's under the heart suit, but it's a red card. So technically I'm down to 25 here. And I'll go 26 minus ace of hearts. Look at that. 25 out of 50 is your last entry there. So it's 25 over 132, 600. And my odds would be 25 to 132, 575. And that's how it goes. Circle or highlight without replacement. This is what tells us that this is dependent event. The first one affects your second one. It just does because you're not putting it back. Your probability changes. It doesn't change by much because you're only taking one out, but it does change. Okay, so that's the important thing. So that is the key of today's lesson, is to understand that if it's without replacement, that we are now talking dependent events. So you have to watch out. Your total is definitely going to change as you go along. Okay. What else do I have for you here? So let's do at least questions 1 to 3. If you get to 4, that's great. But I'm going to ask you to take a few minutes. This is your AC for today. Try 1 to 3 on page 42. Some good questions. So I want you to just make sure you pay attention, okay? If it ever says, this is notation, and notation, understanding notation is very important. If you have probability of A and B, we just say probability of A happening and probability of B happening for independent events. So that's when you replace it. Okay, I'm going to give it a different color. What am I saying with that? What am I saying with this? I'm saying if you ever on a textbook or my test or anything ever just shows you this, you know that these two things are happening one after the other, but things are being replaced. There's nothing fishy happening here. Okay, you're always resetting everything. However, if the events are dependent, you're not replacing. I'm going to give this one a different color. We have a slightly different notation. Do you notice that change? It's very subtle. Everything else stays the same, but what is different? It's this one right here. Do you remember how to read this? This is saying probability of B happening. That's an event. It could be a red queen, an ace, a red marble, whatever. Given that A has happened, so this is giving you a hint, the first event is going to affect my second event. Something has not been replaced. So you need to account for that. So I would like you to have these two notations on your study sheet somewhere. And that right there is probability of B happening given that A happened. I found a cool coin today. I was cleaning some stuff. It's from the Philippines. I don't know why it was there. What is up here? I was removing boxes and it fell. And that's pretty cool. But anyways, so that's a peso, I think. Is it peso or peso? I don't know. What do you call? Peso? Yeah, peso. Okay, anyways, for a coin, which camp would it be under? Will you ever have to worry about, like if this lands on heads, first event, do I ever have to worry about the probability of it landing on heads again on my second event? Do I have to look back at what happened first? No, because it doesn't change. It doesn't affect at all. So this will never be an issue when it comes to a coin or a die or dice. It will never be. You just have to worry about, well, what is it for heads the first time? 1 out of 2. What is it for heads the second time? 1 out of 2. It doesn't change. But this one would be a cards event or marbles event where you're not replacing things. So you have to consider what happened first. You have to look back. It's like what happened first, because it's going to affect what happens next. I know it's annoying, but you need to. I want you to understand the notation if it ever shows up. So here we go. Let's just go over this, and then we'll do some more stuff. So we have a deck of cards. We're not replacing. Please remember, when that happens, highlight that. And a second card is chosen. The probability of the first card chosen is a queen. What's the probability of the first one being a queen and the second one being a jack? You know this is going to happen because you're not replacing. For sure, 52, 51, that should be a given. Then you look at what's the first thing? A queen. There are 4 out of 52. That's the probability of the first card being a queen, guys. It's not saying you're drawing 4 cards. It's just saying there are 4 chances out of 52 that that's going to happen. And then next one is an ace. A jack. What am I saying here? Jack. How many jacks? There are 4, correct? The first one didn't affect the number of jacks, so it's still all 4 that were right from the beginning. Okay, so that'd be 16 out of 2652, and we're just going to leave it at that. Okay. The next one, Miss Yosik needs 2 students to help her with her demonstration from her class. 18 girls, 12 boys, so that's 30 total. She randomly chooses one student who comes to the front of the room, then chooses a second one from those that are still seated. I hope that this, right, chooses one student and then chooses a second student from those that are still seated. What is that telling you? That the first one is not going back, right? One has been removed. So I will make a note here. A student has been removed and not replaced. So dependent, therefore dependent. So I'm going to be annoying here with notation. Please write that on the margins. Write it somewhere. Which formula are we going to use? Orange or green? Green, right? How would we translate this? Probability of a girl and a girl would be probability of drawing a girl and the probability of drawing another girl, given that the first person was a girl. That's kind of like the notation that I want you to follow. You don't have to write down the formula, guys. You can go straight down to numbers. That's okay. But if you ever see it, I want you to recognize it. So how many girls at first? 18 out of 30. At the very beginning, for the first one to be a girl, that's 18 out of 30 chance of that happening. You're not grabbing 18. You're just grabbing 1. You're selecting 1. Okay? Next, you're down to 29. And this is why we use this notation. We've got 17 left, right? And so that's that. And so 18 times 17 is 306 over 870. Boom, you're done. 20 computer chips out of 20, right? A shipment of 23 are defective. 3 computers are randomly selected and tested. What's the probability that all 3 are defective if the first one and the second ones are not replaced? So basically what they're saying is you're not replacing as you're drawing. That's dependent right there. So probability, in this case, we'll just go with numbers. 3 over 20. That's the chances of the first one being defective. Now you're down to 19, right, for the second one? And there's 2 defective ones because you've already grabbed one of the defective ones. Next is 18, and you're only down to 1. So it's 3, 2, 1, that's 6, and the denominator is 1140. Boom, you're done. Question. What if this question had read, you're paying attention, right? You're writing this down, that's fine. What if the question is there, what's the probability of the first 2 being defective and the last one not being defective? It would still be 3 out of 20, 2 out of 19. How many are not defective? Like if you're doing the very last one, there's still 18 left, correct? That's not going to change. But how many non-defective do we have? 17, right? They've not been removed. They've technically not been removed. So this would have been 17 out of 18. And then you do it that way. So I'm not saying that's very common, but just read carefully. Next. The probability of a queen of spades. We're drawing one after the other. And the card has been replaced. Okay, so this is what? What kind of events are we talking about? Independent events. That's basically most of what we were doing so far was independent, especially if it's dice, if it's multiple choice questions, anything like that, you were independent. So we're drawing, Queen of Spades is gone. Queen of Spades is gone, has been replaced though. What's the probability of drawing a Queen of Spades and a face card? So Queen of Spades, we've got one Queen of Spades, and we're back to 52 because we're replacing it. And so how many face cards? 12. So that's 12 over 2704. And odds would be 12 to 2692. So basically I just subtract, these are your odds here. I just subtract the 12 from the 2704 to get my, right, non-favorable outcomes. The probability of drawing a Queen of Spades and a black card if the first card is not being replaced. Dependent, right? I think you're going to have dreams of that after this. Dependent events, I can't handle it. So drawing a Queen of Spades, there's only 1 over 52. And because you're not replacing, you're definitely down to 51. And a black card. Do I need to worry about the first event when it comes to the top number? Yes? You didn't get what? You get a different denominator? Everybody? Why don't you stop, you guys? 6840, is that more like it? I read the reduced fraction, my bad. Thank you. My YouTube fans are going to give me a thumbs down if I mess up too often. Anyways. Are we good now? We got that out of the way? That's fixed. Okay, thank you. 52 down to 51 because we're not replacing. I think that makes sense. How about this, though? A black card. Do I have 26 to put in here? No, because the Queen of Spades is a black card. Okay? The queen of spades is a black card, so you're down to 25. So this should be a 25 over 51. And if you multiply, you get 25 over, let's get this one right, 2652. No complaints? I'm gonna get one of those, I went to a store once and they had like a mouse trap and there was a button there, press here for complaints. Found that was pretty funny. Anyways, I'll stop